Hey guys, welcome to this video. So in this video we are going to understand whether a database is OLTP or OLAP system during the performance analysis of a particular database. So imagine that a database is having a performance issue and you are having an AWR report. So either you are inside a project and you generated the AWR report and you are trying to interpret, or you are getting the AWR report from a customer's remote site and you want to understand what type of database that you are going to what type of database is having a performance issue that you are going to further analyze, right? So it is very important that you need to understand the type of database before you dive down deep into the performance analysis. Okay, so generally database can be OLTP. OLTP you already know, right? So it can be a banking system. So every transaction processing will be banking system. Okay, so apart from that there are also other transactional processing applications or business, but still majority of the transaction processing systems would be banking applications. And there are other analytics applications and analytics projects and businesses, so that come under data warehousing, OLAP, analytical processing, right? So why you need to understand the type of the database, right? So generally whenever you are troubleshooting any issue, if the system is an OLTP system, then obviously it will be write dominant, and OLAP systems would be read dominant. Okay, so this is just an estimation, or this is just a generic perspective. Okay, this does not mean that OLAP systems would not be doing not even a single write, or OLTP systems does not even do any single reads. So this is just a perception, that's it. So based on the prior experience and all the application working, obviously the system itself is designed in such a way that the OLAP will read a lot of data, a huge batch of data. So OLAP systems totally focus on the throughput, right? The amount of processing or the work done for a given amount of time. It does not focus on the response time, but OLTP completely focus on the response time, right? So how much time the transaction is processed, that is very important in any banking systems. So obviously in banking systems there will be a lot of modifications happening, right? So say for example I am spending money, right? So I have 10,000 rupees in my bank account, and I'm just adding I'm getting 5,000 rupees amount credited. So this has to be changed, 15,000. Again, if I spend 3,000, so I have to subtract this 3,000 with the 15,000, then I get 12,000. Right? So likewise, based on the transaction that we do, right? So daily there will be obviously millions of customers doing millions of transactions. Even for a small amount, you will be doing an online transaction. So now if you see, almost most of the transactions are happening via UPI, right? So there are a lot of UPI applications as well apart from the banking, right? So you use the credit card or debit card. Apart from that, you also use the Google Pay. You have Paytm and PayPal and a lot of other online transaction processing, right? So obviously, even a single person today, it's not it's unavoidable, right? So it's inevitable. So we have to do at least minimum 10 to 20 transactions per day if we go out and if we purchase something, or if we travel somewhere, right? Or if we have some food outside, right? So every transactions happen online. So obviously lot of modifications would be happening in a transactional processing. So majority of the transactions would be write dominant in OLTP. But for OLAP, we don't do any transaction. OLAP is kind of an analytic, so we are just analyzing the historical data from the past, right? So you can take Amazon as the example, e-commerce Amazon, or you can take any analytics systems, analytic companies, right? So in Amazon, what they do, they just analyze the historical sales information. So how many products were how many products got sell in the previous last 6 months or 1 year or past 2 years. It's very we can say it depends on the business, right? It's very vast. So every e-commerce company would be analyzing their historical data, and based on that they offer the discounts, they sell the products with a lesser price, right, based on the historical analysis. So that's how the business gets the profit and the business runs smoothly, right? So in today's world, without any analytics, it's kind of very difficult to survive the market, right? So let us come to the AWR perspective. Why we need, what is the relation between knowing the type of the database system and the real-time use case. So as I already mentioned that OLTP would be a write dominant and OLAP would be a read dominant. So based on this itself, we can focus your analysis, right? So it's not only OLTP and OLAP, so there are also a mixed workload as well, right? Mixed of both OLTP and OLAP. So we cannot say that a specific application will be completely OLTP or it may be completely OLAP. It may be a mixed of workload as well. So we have decision support system, DSS. So how you will identify based on the AWR report? So just go to the load profile. Okay, here in load profile, if you see, we have read IO request, write IO request, read IO MB, write IO MB. So based on this itself, we can easily identify, right, whether the system is read dominant or write dominant. So if you see, this system is having a lot of reads, comparatively less writes compared to the reads, right? So read IO requests are very high, almost 4,386 per second, and per transaction 47,000 per transaction. But write IO requests are only 12.8, and read IO MB is also very high, bandwidth is high, right? So based on this, you can easily understand that this is kind of an OLAP system, okay? Because definitely in a transaction system there will be a lot of modifications, writes. So executes also would be very high in the OLTP systems, okay? But here, if you see executes, we see executes as well. So even for DML transactions like insert, updates, deletes, executes may happen. Okay, so execute is the last stage of the SQL processing. Like initially the SQL would be parsed, right? Then it would be fetched. Okay, the third one is execute. Parse, fetch, then execute. So if it is a select statement, then what the SQL processing does, it will parse the SQL, then it will fetch the data. That's all. If it is a insert, update or delete, what it does, it parses, fetches, then also it will execute the statement on the disk. So it is kind of a write. So here we see executes also 223. Okay, so this means we do see writes as well, but not very high. It's comparatively reads are very high. So if you see physical reads are also high. Okay, and physical reads and logical reads would not conclude that it is a OLTP or OLAP system, but mainly you have to focus on the read IO request and read IO MB. So that will confirm whether it is a OLTP or OLAP, and also you can check the number of user calls and the parses. So generally in a OLTP system there will be lot of user calls. Okay, so comparatively to an OLAP system. So this is kind of a mixed workload. Okay, so here we cannot conclude that this is an OLTP or OLAP. So we have both have reads and writes. Okay, but if you see the reads are quite high compared to the writes, and you need to keep in mind that user calls will be very high in a OLTP systems. And also in OLAP systems the parsing will be very less, because in OLAP systems there will be a lot of reads. So obviously the SQL statements would be stored in the shared pool. So for less parse there will be a lot of executions. Okay, but in OLTP systems there will be high number of parses, because every SQL statement that will be executing would be different. So obviously there will be a lot of high parsing that may happen in an OLTP systems. Okay, and also the user calls also would be high in an OLTP systems, but in OLAP user calls will be quite less. And you can also check the number of commits and the rollbacks. So user commits. So if you see, if the number of commits and the number of rollbacks are high, then this concludes that it is an OLTP system. Okay, so if the number of commits are quite less, then obviously in OLAP systems there will be less commits comparatively to OLTP systems, right? Obviously you know that DML transactions require a commit. So if there are a lot of reads, then we don't need a commit or rollback, right? So you need to see per transaction how many commits happen. So only 0.67 commits are happening. So obviously this can direct us towards OLAP system. This is not an OLTP, right? So initially we already saw that there were a lot of user reads, a lot of read IO requests comparatively to write. And in OLAP systems again we have work area executions, right? So if work area executions are quite high, then that means that it is an OLAP system, because obviously there is another perspective that OLTP will be using SGA a lot. OLAP systems will be using PGA a lot. So work area executions will be related to PGA. So if work area executions are very high, then that is an OLAP system. So likewise, there are a lot of other metrics, okay, that can be used as a hint to identify the type of the systems. Okay, so now based on all these observations, I conclude that this AWR report that I'm having is an OLAP system. Okay, even though I see there are few commits, and also I see quite a few executes, but still comparatively between the reads and writes, the reads are very high. This AWR report is read dominant, right? So even if you see the top wait events, I see direct path read as the dominant comparatively to the writes. Okay, so obviously this report will be this report was generated from an OLAP system. So based on the SGA or PGA usage itself, we can identify. Okay, so likewise you can learn a lot of different other techniques and hints for your real-time analysis. Okay, so I'm just going to conduct a live real-time performance diagnosis with the case study training. Okay, in the coming September, it will be conducted on September 29th, 2026. So I'll be just sharing a Google form in the description of this video. So if you are really interested and if you want to make your career further in terms of learning and also to thrive in your day-to-day performance troubleshooting, then you can just fill the form. Okay, so based on the responses, I would be updating you on the schedule of the training and for the upcoming batch. So I will be providing you the either the daily schedule or the weekly schedule, and the course fee, and what you will be getting out of this course, right? So I will be giving you all the link to the description of this course, like what you will be learning and what you will be your goal, right? So you need to give what is your goal as well, so that it would match your aspirations, right? So I know that there are a lot of people who still may need some help in terms of a real-time performance troubleshooting, because troubleshooting is a skill which cannot be taught to anyone, right? And it should be built personally based on the experience. So I'm just going to share my experience with you so that you don't need to find it difficult, or you don't need to get pressurized or tense in troubleshooting any critical issues, right? Obviously, if you are a DBA, one or the other day, definitely you would be in a situation where all of your management and all of your business stakeholders and your higher management and everyone, right, would be joining a call for a critical production performance failure or any slowness, right? So as a DBA, if you are suddenly involved in a bridge call, right, so you need to immediately, at least if you are not giving a solution, you need to know what is the cause. That is very important, right? So giving a solution is not that easy, right? So in a real-time production system, it is not how we think, like it is not how we think, like changing a specific parameter or increasing the resource, or it's not like that. Everything has to go through specific change window, right? So even if it is a minor modification, we need to, in a production system, we need to go via change window, but we need to first narrow down the costs. That comprises 90% of the troubleshooting rather than providing a solution. So obviously 95% of the time that you will be spending would be to identify the costs. Only remaining 5% you will be focusing on the solution. So without knowing the costs, you will not be able to do implement any solution. Okay, otherwise it would be like a blind trial and error method. So that is completely different. You cannot do trial and error on a production system, right? So without identifying what exactly is the cost, you cannot apply all the 100% of the solutions that you have in your hand. Okay, so that is the main goal of conducting this training, okay, to help you with the day-to-day performance troubleshooting, and whatever shortcuts and whatever hints and whatever easy way that I developed and designed for my personal ease, right? So to make sure that I am not spending much time on any analysis. I have just shortened all the diagnosis and analysis, and I have just refined my troubleshooting skills, so I can just provide you all my experience with you by providing you this training. Okay, so this is not about learning about any specific concepts of performance training. This is completely a case study, so you'll be learning the real-time performance case study. So in case if you face a performance issue tomorrow, you will definitely know what to do, okay, to identify the cause and give a justification. So that is the main goal of this training. Okay, so hope you would be filling the forms which is provided in the description, and I will also give you more detail about the training in the upcoming days. Okay, so thanks for watching. So hope you would be giving your feedbacks and giving your details in the form.